Okay, so let's keep going. So the next thing that we're going to do here is we're going to call G, and we're going to pass it C. Note that C is a local variable in A, so we don't need to look any further to find C. Note also that G has the parameter in G is a reference parameter, and that's going to have some ramifications when we draw G's stack frame, which we should go ahead and do. So we will need a return address for G, and again, remember that we are going to just use the same line number of the call. So the return address here is going to be 26. We're going to have static and dynamic links again. And so we need to think about what these will be. Well, the dynamic link is always going to be initialized to point to the activation record for the subprogram that called the current program. So G was called by A, so the dynamic link there is always going to point back to A. And then what about the static link? Well, to answer that, we have to look at where G is defined. So G is defined here, and its immediate enclosing lexical parent is A. So A is also going to be the target of the static link here. So thus far, we haven't seen any situation where the static link is different than the dynamic link. That will obviously change at some point in this. Okay, so we've set up the static link, the dynamic link. We look back up here to see what else we need. We need a return value if, in fact, G does have a return value, which it does. So you can see that right here. So G has a return value. So we want to reserve a slot for that, so for the return value. Now, if this is sounding a little bit strange to you, that's fine, and it should, because in 261, we talked about y86 and x86, which handled return values using a register, namely EAX or RAX on the x86 and x64 architectures. So this is just the calling conventions that have been laid out in the lab, and so if you're a little confused about that, just be aware that this is describing a hardware architecture that is not x86, right? Because we're storing the return value on the stack. Okay, and then any parameters. So we do have a parameter. So we have a parameter called x. And the important thing to note here is that x is a reference parameter. So this is essentially just a pointer or a reference to something. And I am going to draw this in a different color so that we can make it a little bit more visual. So C is what's passed in from A. So that means that X really is just kind of a pointer down to C. So anytime we use X inside of G, it will be C from A. All right, so then, so that's the parameters. So does G have any local variables? Yes, it does. It has one local variable called R. We don't have a value for it yet. And so this is the activation record for G. All right, so now we'll trace through G. So the first thing that G does is it decrements X by 1. So there is an X in G. It is, in fact, just a reference to C. So essentially, this is going to decrement C by 1, which means that instead of 2, it is going to be 1. I should probably fix my little square here. All right, so that is the effect of that decrement operation. And then we're going to call f. So note that we need to do both this part and this part. So again, this is why we're using the return addresses of the line where the call happens, because there's still something that we need to do once this call finishes. So we do want to call f. So we need a new stack frame for f. The return address, like I just said, is going to be the line where the call to f occurs, which is line 19. We need static and dynamic links, as always. So G called. So I'm going to go ahead and erase these because we haven't been keeping them up to date. Whoops. We'll draw those back in when we get to location 2. So the dynamic link for f is going to be G. And the static link for f is still going to be a. So now we've gotten to a point where the static and the dynamic link are different. So the static parent of f is a. The dynamic parent of f, in this case, is going to be g, because g is what called f. So the static link now is going to point back. And this is where it's helpful to kind of have one vertical line in your drawing for each of the activation records, because it makes it easier for you to go in and connect up these lines. So so that is pointing back to A. We need a return value because f has a return value, so we'll reserve a slot for that. And then there is one parameter to x, which is, or to f, sorry, which is x. Note that this one is not being passed by reference, so this is just a standard pass by value parameter. And so here we're passing in x. Again, we have x here, which is now currently has a value of 1. And so that gets copied into f's stack frame. And then we also have one local variable inside of f. And this is going to be r. Okay, so this is our stack frame for f. But in fact, if you look ahead a little bit, you'll see that it is not going to be our only stack frame for f, because we're actually going to call f again inside of f, because the x value that we have here is greater than 0. But before we get there, we need to do this assignment here. So b equals 5. So there is no b inside of f, so we need to follow the static link, and that'll take us all the way back to a, where we find a b. So it's this value here. So we can go ahead and set that to 5. So I have to be careful with my erasing. Okay. All right, so that's going to set that to 5. I'll repair my box again. All right, so then after we do the x equals, or b equals 5, then we check x to see if it's greater than 0. We're in f, so that means that we're using this x here. And that x is greater than or equal to 0, so we would need to come in and execute this. We always execute operands left to right, so that means that we need to go ahead and evaluate this b. So we'll go ahead and take a look and see. So it's going to be the same b as we just set to 5, so maybe we didn't need to think about that too much. So I'm just going to write this out here. So we're going to save this value because we're going to need it once we get this return value. So this is the next thing that we need to do. And so we're going to have, so we can see that we're going to call f again, which means we're going to need another activation record for f. So this is line 10. So that's going to be the return address here. And I'm going to need to write a little smaller, I think, here. So then we also need a static link and a dynamic link. Again, the static link is always or the dynamic link is always the thing that called you, the caller. And in this case, the other invocation of F is the invocation that called F again. And so the dynamic link here is going to point back to this F, whereas the parent, the lexical parent of F, is still A. So its static link is still going to go down and connect up to, let me draw that a little more carefully. It's still going to connect up with that long chain that points all the way back down to A. Okay, so we do need space for a return value. We have a parameter called x, and the value that has been copied in here is going to from this invocation of x, so this invocation of f. So we're going to calculate x minus 1 as the new parameter value. So x here is 1, so 1 minus 1 is 0. Which incidentally is nice because that stops our recursion here, right? So f essentially recurses until its parameter is 0, at which point it kind of bottoms out. So we're glad that this is going to be the end of our recursion. And then we just need our that last local variable r. So this is now going to be, so this is another invocation of F. So we have two stack frames that correspond to the two activations of F. The first was called by G, and the second was called by F itself. Okay, and at this point, we are almost to location 2. So we are in the second invocation of F, which sets B to 5, which it's the same B, right? They have the same, these two invocations of F have the same static link, so they're going to go to the same B. So it's already set to 5, so that assignment's not going to change anything. Now, X, because we're in this stack frame, so the second invocation of F, X is 0. And so now that X is 0, we can execute this, which sets R to be B plus 1. Well, B plus 1 is going to be 6. So R here is going to be 6. And at that point, we have now reached location 2. So before we go on, I just want to show you this stack in its entirety. And you can hopefully, if you look ahead a little bit, see that this is the deepest point on the stack. So from this point on, we're just going to be removing things from the stack. But before we do that, I just want to point out where the stack pointer and the base pointer are. So the stack pointer is always going to be pointing at the top of the stack. So that's where the stack pointer currently is. And then the environment pointer or the base pointer is always pointing at the base of the current activation record. So this is where those pointers would be at location 2. So I can't, unfortunately, get everything on one screen. I can't zoom out far enough. But that's the top half of the stack, and this is the bottom half of the stack. So that is that diagram in its entirety is the answer to the second problem.